So, what happens when artistic rules from, like, the 1950s smash right into the technology we're all using today? We're going to talk about the soul of animation, these core principles that were made for classic characters, but now, well, now they're in a world they were never, ever built for.
Which brings us to the big question, right? And believe it or not, this is a huge debate. Should the little buttons you tap on your phone move, like, say, Mickey Mouse? Or is that just a fundamentally terrible idea? Let's dive in and find out.
All right, so to really get this debate, we've got to go back to the beginning. We need to understand the classic rules of motion, the very foundation of how we make things move on screen.
Yeah, these rules didn't just, pop into existence. They grew over more than a century of amazing innovation. We're talking everything from accidental discoveries by pioneers like Georges Méliès to animators in the early 20th century making puppets out of actual insect exoskeletons. No, seriously. And then, of course, you get Disney in the 50s making their principles the gold standard, all the way up to today with studios like Leica using things like 3D printed parts. It's always been a story of art pushing technology forward.
And the whole point of all of this? It was all about one thing: giving characters the illusion of life. All those famous techniques, squash and stretch, moving in arcs, the timing, it was all about making us believe that these drawings or puppets were actually alive, that they had weight, a personality, maybe even feelings. They were designed for characters. Okay, so now let's fast forward to today, because this is where the fight really starts. What happens when you take these rules made for characters, and try to apply them to the user interface on your phone? Well, that's when things get messy.
So here's the heart of the disagreement, right? On one side, you've got classic animation. It says living things move in arcs, because we have bones and joints. It just feels natural. But on the other side, a lot of UI designers are like, hold on, a button on a screen isn't alive. For them, a straight diagonal path is just better. It's more direct, it's efficient, it's, well, robotic. And maybe, just maybe, that's exactly what it should feel like.
And you see this viewpoint all over the design world. Take this comment from Reddit user Schroeder8, who basically says, look, I'm just not convinced these principles for characters work for UI design. It just makes more sense for a screen element to feel robotic. The context is totally different.
And another user, Kamamil, puts it even more bluntly. They say these rules are for 1950s character animation, not animation of user interface elements or text. It's a great point, right? It's like trying to build a website with a hammer. The tool just wasn't made for the job.
But the argument goes way beyond just it doesn't fit. For a lot of people, the frustration is real. It's palpable. It gets to the point where some call this kind of animation UI cancer.
And wow, here it is. This is probably the most powerful argument you'll see against bad UI animation, from Reddit user Matt Svensson. Delay animations like that is nothing but UI cancer. They're saying nobody wants to sit around and wait for your little animation to stop being all rubbery and bouncy. People just want to use the app. It's all about frustration.
But okay, wait a second. Does that mean all motion is bad? No way. Even the harshest critics will tell you that motion does have a purpose. In fact, the right kind of motion is totally essential. It's what tells you what's happening on the screen. It shows you that your tap actually did something. It helps you understand the whole interface instead of just randomly tapping and guessing. This is especially true on our phones.
So that's really the key takeaway here. The argument isn't about animation yes or no. The old rules might not fit, that's true. But motion itself, it's absolutely crucial. It's about finding the new rules for our digital world.
So, if the old rules don't work and we need new ones, where do we look? Well, this is where it gets really interesting. What if we could just teach machines to figure it all out for us? This brings us to something called physics-based animation. So think about it like this. Instead of an animator handcrafting every single frame of a movement, the motion is generated by a physics engine. The goal is to create movement that feels real, because it actually follows the laws of physics, reacting to its digital environment just like you or I would react to the real world.
And check this out. There's a system called Paddle that takes this whole physics thing to the next level. The crazy part, you can direct it just by typing simple natural language commands. You don't have to be an expert animator or a coder. You literally just tell it what you want it to do. This isn't just a new tool, it's a completely different way to think about animation. So how on earth does this work? Well, it's kind of like teaching an AI a new language. The first step is what they call skill embedding. It's like you're showing it thousands of video clips and tagging them with words: walk, jump, run. It's building a visual dictionary.
Then comes policy training, where the AI agent learns to actually do those skills when it hears the word. And finally, the coolest part, multitask aggregation, where it starts to string those skills together to follow complex commands, like go to the blue target. It's learning to have a real conversation, but with motion.
Okay, let's zoom out and look at the big picture here. We've seen the classic rules, we've waded into the modern debate, and now we're getting a peek at a future that's being driven by AI.
And this really shows you the power of it all. What you're seeing here is a comparison. On one side, you've got the original motion capture data from a real person. On the other side, the final animation that the AI generated inside a physics simulation. See, it's not just mindlessly copying the movement. It's actually understanding the physics behind it, the intent. It's emulating life, not just tracing a picture of it.
So in a way, we've come full circle, haven't we? From the very first animators trying to create that illusion of life by hand, to today, where we have an AI learning to do the exact same thing through simulation. The goal is exactly the same: make natural, lifelike motion. It's just that the tools are, well, they're radically different. And maybe this is the real answer to that whole UI debate. Maybe it's not about finding one set of rules, but about having technology that's smart enough to create the perfect motion for any context automatically.
And Matt leaves us with a pretty mind-bending question to think about. I mean, animation has always evolved with technology, from those insect parts to 3D printers and now to physics simulations. So as technology keeps getting faster and smarter, and as AI starts to understand not just how things move, but why, you have to wonder, what is the next illusion of life even going to look like?